Let's finish up on the homework for 7.2a over disk method. So our functions are y equals e to the negative x, given by this curve here. Y equals 0, that's the x-axis. X equals 0, the y-axis. X equals 1, this vertical line here. So we see that the shaded region includes boundaries that's contributing from each of the lines and graphs. Okay. Axis of revolution is on the x-axis, so I draw a dotted line here and also indicate that this is the center of our graph. We're rotating this shaded region about the axis. We draw our radius from the axis of revolution to the curve, and then we determine top minus. We see that these are vertical radius, so everything we have to use top minus bottom form, and everything will be in terms of x. So our top graph is e to the negative x. This is the curve. Our bottom graph is 0. That's where the bottom of this radius is hitting. So e to the negative x minus 0 is simply e to the negative x. That's our radius. And our bounds are from 0 to 1. 0 is the furthest left the graph goes, and 1 is the furthest right the shaded region has going. So bring this up back to the top, e to the negative x squared, which is e to the negative 2x. If we go through u substitution, u is negative 2x, derivative is negative 2, dx is du over negative 2. This negative 2 is going to be a coefficient that we can pull out, which so negative pi over 2 e to the u. And because we're going through u substitution and we are plugging in upper and lower bounds, we have to make sure we convert our x values to be in terms of u. So plug in 0 in for x, we still get 0. Plug in 1 in for x, we're going to get u is equal to negative 2. Upper bound minus lower bound, so e to the negative 2 minus e to the 0. This simplifies to be 1 over e squared minus 1. And we don't want to forget the coefficient of negative pi over 2. And that we can simplify that or use our calculator to get a decimal answer 1.358. Okay, 31. We have y equals 3 times 2 minus x. Linear function, y equals 0 and x equals 0. So it's going to create a triangular graph revolved about the y-axis. So vertical line is the center of our graph, revolved around it. So starting at the center, starting at the axis, we're going to draw to the graph. So we drew a horizontal rectangle, horizontal radius, meaning that everything will be in terms of y, and we're doing the right minus left method. So if you look at the right graph is hitting the 3 times 2 minus x. The left graph is hitting the 0. Okay. Now, because everything has to be in terms of y, we have to make some adjustments with our equation. So if I distributed this through, y is equal to 6 minus 3x. Solve for x, I get 3x equals 6 minus y. Continue to solve for x, divide by 3, I get negative 1/3 y plus 2. So my radius is simply the right minus the left. We said the right is the linear function, so 2 minus 1/3 y. And the left is 0. So we get r of y is equal to 2 minus 1/3 y. We also need to find our intersections because everything's in terms of y. We see from looking at the graph that the lowest y value is 0, but the highest y value of the shaded region is going to be at the vertex of this triangle. So the way we do that, we find that we have to set the equation of this line with this line x equals 0. So we set 2 minus 1/3 y equal to 0. Bring the 1/3 y over to the right. Cross multiply, we get y equals 6. Lower bound is 0, upper bound is 6. R squared, so 2 minus 1/3 y squared. We can expand, go through power rule, plug in upper and lower bounds, and this simplifies to be 8 pi cubic units. Okay, 45. The problem is asking if we have a region bounded by 4x minus x squared and the x-axis revolved about the x-axis, how does that compare with a shaded region that's bounded by y equals 4 minus x squared, bounded by this new function, the x-axis, and revolved about the same line, the x-axis. Okay, so if we graph this, we see that this is basically the same graph. It's just going to be shifted over horizontally. So because the shaded region has the same area, if we're revolving it about the same line, the volumes of these two solids are going to be identical because the shaded regions are simply the same. They're just translated horizontally. Okay, 53. The problem gives you the diagram with the curve 1/8 x squared, square root of 2 minus x. Axis of revolution is of rotation is the x-axis. So it's the center of our graph. So this graph will kind of look like a teardrop that's that's sideways. And so we know we have to go through top minus bottom formula, because if we're starting on the axis and we're drawing to the curve, we're drawing a vertical radius. So we do top minus bottom. The top of the radius is hitting the curve, which is 1/8 x squared, square root of 2 minus x. The bottom of the rectangle of the radius is hitting 0. So we simplify that to be simply 1/8 x squared, square root of 2 minus x. And our bounds are from 0 to 2. Okay, from here, we plug into our formula, pi r squared. If we square everything inside, we're going to x to the 4th over 64 times 2 minus x. Pull out the coefficient, pi over 64, go through power rule on the inside here. And once we're there, then plug in upper and lower bounds. Simplify to be 32 over 15. But don't forget, there's that leading coefficient, pi over 64, that we have to include in our final answer. Simplifies to be pi over 30 cubic units as our volume.